Problem 17, we're going to recast what we've been doing in terms of solving equations. That's really what's been going on in the background. And so what this is asking is to find all solutions to z to the fourth plus 1 is 0, or equivalently, what we're looking for are all the fourth roots of negative 1 by subtracting 1 from both sides and taking the fourth root of both sides. So, again, we know that the argument of negative 1 is pi. We know that the modulus of negative 1 is 1. And we're looking at the fourth roots of 1. So, what did we get? Well, we found one of them earlier in problem 2 in the previous video. One of them looked like that. The other ones were, if we were to look at our picture, we're not going to rely on the formula here. So here's our W0. The other ones were given by the 4 equally spaced points on the unit circle. Well, if this one has coordinates root 2 over 2 plus root 2 over 2i, I think it's pretty easy to guess what the other coordinates are. So W1 is most likely negative root 2 over 2 plus I root 2 over 2. W2 is most likely negative root 2 over 2 minus I root 2 over 2. And W3 is most likely positive, because W3 is positive real part. Positive root 2 over 2 minus I root 2 over 2. And by most likely, of course, I mean it is equal to that. And if you use the formula, you would find that that's the case. And so these are all the fourth roots of negative 1. And also, consequently, they're all the solutions to the z to the fourth plus 1 is 0. And this is a general fact, and it's one of the reasons why we have these nice, we desire a formula for the nth roots, is because the nth roots, it's just a general fact. Well, I don't even have to say general fact, it's basically obvious, but it's important to remember the nth roots of a complex number correspond to solutions. Well, it's not an implication. Let me say correspond to solutions to z to the n minus a is 0. Now we could be a little bit more theoretical about this correspondence. So we can say the collection of nth roots for a fixed complex number is the same as the w's in the complex numbers, such that wn minus a is the same set.